your basic technology teacher. I want to take you on basic technology GSS1 class. Hope your holiday had been so wonderful, and I hope you really enjoy your holiday. Now I want to look at the first 3 weeks topic that we're going to handle when we come into the classroom for GSS1 class, basic technology. The first topic we're going to handle for the first 3 weeks is going to be what we have on the board, basic ideas of electricity and magnetism. Basic ideas of electricity and magnetism. You know, before now, at our different places, we know what electricity is all about. We know what we mean when we talk about electricity. But this time around, I want to go more, because this is the basic that we have to know before advancing on learning more on this topic. Now, what do you mean by basic idea of electricity and magnetism? We're talking about how electricity come to be, how the scientists were able to come out with the electricity charges. Now, this happened about 2,500 years ago, when the Greek scientist called Thales discovered on the seashore one yellow substances, orange substances, which he called amber. Then he began to carry out experiments on this amber. He discovered that this substance was able to magnetize some other light materials. Then he now began to carry out some work to find out what causes this. And in doing that, he moved into the lab. This orange colored amber, which I called substance that was gotten from the seashore, was the one that contained these charges. Now, his work was to find out what really makes this substance behave in such a way. What causes the charges, and then why does it behave like that? Then in doing that, we now move to discuss about the electric charge. We say electric charge is the fundamental entity responsible for electric and magnetic phenomena. Before we discuss about electric or magnetic, there is no how we are not going to talk about charges. Now, these charges, by that experiment that the scientist Thales carried out, discovered that the charges present making this substance to behave such a way that it could attract some other light object was the 3 major charges we discussed today. Talking about number 1, the proton, number 2, the neutron, and the third one is the electron. So, in the course of his experiment, he was able to know that these 3 charges are present in every material. Now, we say every material, it takes us to the definition of what we call matter. In our basic class, we've been told that matter is any material that has mass and occupies spaces. Now, it means that in every matter, there's this presence of proton, electron, and neutron. Now, the proton is one that normally carries the positive charge, while the neutron carries the neutral charge. The electron will carry the negative charge. Now, in every substance, these charges must balance out. What do I mean by that? The number of protons should equal to the number of electrons. For example, the simplest element we can consider, hydrogen. Hydrogen in the elementary table is the number 1. We said hydrogen has 1 electron. It means that in hydrogen, we have 1 neutron, 1 proton, and 1 electron. Let me try to sketch something on the board here. Now, this is proton. I call this hydrogen. Now, hydrogen, we know that it contains 1 electron. Inside the nucleus, this is the total nucleus. I can call this nucleus of hydrogen. Which means in the nucleus of hydrogen, we have 1 proton, 1 neutron, and 1 electron. That makes hydrogen a balanced element. When you have a proton, the proton, like I said, carry the positive charge. This is a proton. This is the electron. And we have the neutron also inside the nucleus. Now, you say this is a stable element. So we can have hydrogen as a stable element. So this element, hydrogen, was one of the materials used by these scientists to explain further how we come about the electric charge and magnetic charge. Now, the next thing we're going to discuss is about atom. We said atom is the smallest indivisible particle of any element. When we say smallest indivisible particle, it means that the least form of that particular material. For example, you can have a stone, you can break it further. When you get to powder level, you don't break further. Now it means stone at powder form had gotten to the point in which you cannot break further. So we say that powder gotten from that stone is the atom gotten from the stone. So when we now define atom, we say it's the smallest indivisible particle of an element which can take part in chemical reaction. Now, we need to know the study of this atom to be able to know how materials behave. More particularly, how we come about electricity and magnetism. Don't forget that I said earlier that they are all what? Charges. They are charges and they are derived from the element. Now, I want to quickly give us the concept of an atom. Now, in the modern concept of an atom, as advanced by the scientist from Denmark called Niels Bohr, it suggested that the electron rotates in orbit around the central body nucleus. The electron rotates around the body of the central nucleus. Now, just the way you see the solar, in the solar system, you see different planets surrounding the sun, and each of them rotate, revolve around the sun. So this is the way these atoms are. So as earlier said, I said proton, neutron and electron are combined together in the nucleus or atom of any element. And I use hydrogen, where you have one electron in hydrogen. That same electron is having what? One neutron, one proton, and one electron. The proton always carries the positive charge. The neutron has no charge. We will say it's neutral. While the electron is one that is always with the negative charge. Now, the proton is bigger and heavier than the electron. The approximate scale being a football field to a pinhead. You can imagine the size. A whole football field being the proton, then the pinhead representing the what? The electron. Now, but these still contain together in the nucleus. Now, I said they are made to continuously what? Move. They move continuously in the nucleus of any element. Though we may not see the movement per se physically, but it is assumed that these proton, neutron, electron are in constant movement, constant random movement in every element that are present. So, because these are in constant random movement and these are charges, that is how we are able to arrive at current. Now, how do we now form current? You see, when you are able to control the movement of this electron and channel it in a particular direction, then you have what we call current. Now, someone may ask, how do you now define current? We say it's a unidirectional flow of electron. A unidirectional flow of electron. Once you are able to direct this electron through a channel, through a particular channel, then you are going to have what we call electron. And what helps us to do this is the pressure. When we come back, when we resume back in the class, we'll be able to go more further on how the pressure affects the flow of electron. Because this flow of electron is not only the pressure that affected it, even the temperature and some other factors had a role to play. So meanwhile, I've said some things earlier before now. Then I may want to give you just few questions. Now, I said in the nucleus of every atom, there is a presence of 3 other subcharges. What are these 3 other subcharges? I don't know if you are working it out at all. Now, these 3 subcharges are the proton, the electron, and the neutron. I said the proton carries the positive charge, the neutron has a neutral charge, while the electron has a negative charge. Now, a take-home assignment which would have to be submitted by the time we resume back in the class will be with a good example. Explain how electrons behave in the nucleus of a certain element. That is, with a good example, explain how the electrons behave in the nucleus of a particular element. You can pick any element of your choice, like I have here, hydrogen. What I expected to mark here is for me to know if you actually know the number of electrons that are present in that particular element you are picking as your example, and then you explain how these electrons behave in them. Thank you very much. When we meet again, we'll be able to mark it in the class.